This is another take on the problem that you posted. We have an incline plane here. There's a box with mass M1 on it, um, and there's a smaller box M2 on the other end of the string. So here, the forces here are a force that's parallel to the incline, right? This is due to the component of the weight of the block, and since the block is moving up at a certain velocity, the friction opposes that is kinetic friction, and that would be downward. Now, of course, the tension is up in this case. Now, for the second block, the tension force is up here, and it's the same as the other tension force there. And the weight of the block is now M2G. Now, what you keep in mind here, you have to be careful that since this block is moving up, this block is moving down. So that would mean that M2G is bigger than T. So when you write the equations for that, it should write M2G minus T. I just rewrote this to show you how to solve the simultaneous equation. So for the first mass, the first block, it's tension minus the parallel force minus the kinetic frictional force is equal to mass times acceleration. It's just a net force since it's moving. And the forces here is the negative of the tension plus the weight, and that's equal to mass 2 times that acceleration. So you solve these simultaneously, the t's drop out, and you could then simplify the algebra and come up with an expression for A. And I got acceleration then is equal to m2g minus the fp minus the frictional force divided by the sum of the masses. And I summarize all the known quantities and calculated them out. So you just have to plug these into this equation. And I get negative 3.94 meters per second squared. Now, once you have that, there's another kinematic equation which says that if there's a final velocity squared is equal to the initial velocity squared, which we have here, plus twice the product of the acceleration times the distance, okay? So we're after distance in part one, so you rearrange this and solve for the distance. You'll get v0 squared divided by the negative of 2a, keeping in mind a is negative value. And if you put in the numbers, you should get 0.787 meters up the slope before it comes to a stop. You may want to round all these to two significant figures. Now, the second part of the question is that, well, once it gets up, what is the minimum amount of coefficient of friction so that this block does not slide down the slope? So in this case, the force due to the component of gravity is still downward. However, now static friction, which prevents it from sliding, is now up. It's an up vector. The tension is still up. So and also now looking at the second block, the tension is up and the M2G, the weight is down. But keep in mind, since this is not moving, right, tension in this case is equal to M2G, which I indicate here. So the equation here, the balance equation, is the tension minus the parallel force plus the frictional force, the static frictional force, is equal to 0. All the forces must balance out. And just making substitutions here, you will get an equation, and you solve that for use of S, which is now the coefficient of static friction. If you do the algebra, you will get this formula and work it out the numbers. You will get 0.1 0.17. I hope this helps. Thank you.